All right, let's review from last time. Chapter 1, Section 4. Remember I told you we're going to break this in a couple parts? Well, on Friday we learned about different types of solutions. Usually you come up with a regular solution, like sometimes it works whenever x equals 9 or whenever y equals negative 3. That's usually when you solve an equation the type of solution you're used to getting. On Friday we talked about two other solutions that you can get. Okay, one is when you have any real number, or all possible solutions, I think I said. Anything would work. Where it's always going to work, where when you solve an equation, you're going to get negative 4 equals negative 4, which is true. It's a true statement, meaning all possible solutions, or any real number. No matter what number you put in that equation for x, it will work. Okay? No matter what number you put in for x, it'll work. You don't have to write this part down. You should have this in your notes. If you weren't here Friday, you don't. Okay? But you're gonna, if you put anything in your notes, put that number 1. You have 3 types of solutions: sometimes, always, and never. Okay? Sometimes is when you have x equals 9, x equals negative 3. Always is when you have negative 4 equals negative 4, or a true statement. And then never is when you have a false statement, or no solution. Meaning, if I come up to solve this equation and I come up with 0 equals 15, that's false. 0 doesn't equal 15. So I would rather have $15 than $0. Okay, this is Friday's review. Okay, if you weren't here Friday, we're reviewing Friday questions.
So what's the sometimes?
Sometimes is when you have one solution, like what you're used to, like x equals 9. If I ask you what the answer is, you'll say 9. X equals 9. That's when it works only when x is 9. Does that make sense?
Yep.
Okay. So now today, this is what you need to write down. This is new. This is another part of Chapter 1, Section 4. Okay? This is another part. I'm breaking it down into different, this is Chapter 1, Section 4, Part 2. Part 1, we talk about different types of solutions. Part 2, we're going to solve equations for specific variables. And then we'll do a Part 3, and then we'll take a quiz over Chapter 1, Section 4. Solving for specific variable, meaning when, suppose you have an equation with more than one variable. So there's an x, a y, and a z. Okay, or there's an a, a b, an m, and an n. Or something like that. You have to solve for a specific variable. Step 1, you're going to locate the variable you are solving for. Find the one that it asks you to solve for. It will always tell you the problem, I want you to solve for y, or I want you to solve for x, or r, or whatever it tells you to solve for. Locate it, and my recommendation to you is to highlight it. Okay, if you don't have a highlighter, use one of mine, or you can use circle it, or whatever, so you don't forget. Step 2, look at what's attached to the variable, and step 3, how is it attached? Is it attached as a fraction? Is it attached as addition? Is it attached as multiplication? How is it attached is what you're looking for. And then when you go to solve for that variable, you're doing it just like you normally do. You're going to do the order of operations backwards. Okay? When you solve for equations, you do it backwards. You do your subtraction addition first. You do your multiplication division next. Then you do your exponents in parentheses. Unfold your parentheses last. Did everybody get that top part? There you go. I'm going to use these steps to solve this equation for A. Everybody see that equation? Make it bigger. Is that better? Solve this equation for A. We're going to solve this equation for A. Meaning, I want A to be by itself. I want A to be by itself. So when I look at that, I'm going to highlight the A or circle the A. If you want a highlighter, I usually have a cup full. They're floating around the classroom somewhere. You can use them. If I need to go buy more, I will.
So like, when we put B with the C.
Okay, now this is the part I need. Okay, locate the variable somewhere. Then look, what's attached to this variable? The x and the bx, right? Okay, by order of operations backwards. Which one do I want to get rid of first, the x or the bx?
Bx.
The bx, because when we solve for equations, we go backwards. We do the addition and subtraction first. So I'm going to subtract bx pretend b and x are just some other number, and you're just, if you would multiply them together, you just subtract that number from both sides. You're pretending these aren't variables. It's hard to do. So I'm left with ax equals c minus bx. Okay? Now, look at what else is attached to the a, that what's highlighted? An x. It's attached by multiplication. So you're going to divide both sides by x. Get rid of the x, you have to do the opposite. You're going to divide both sides by x. Now, suppose you're taking a quiz, or I give you a quiz over this, and I give you a multiple choice. And you don't see this answer in your answer. Okay? Suppose you don't see that answer in there. Does that necessarily mean it's wrong? No, that just means it's written differently. Okay? It's written differently. How do I write this differently? Well, how many of you have seen in your Algebra 1 class where you can go like this? You can actually put the x with the c and put the x with the bx. You distribute that x to each term. So I'm going to have c over x minus bx over x. You see what I did? I put the x here and here. I basically distributed a 1 over x to each part. And then simplify. These x's are going to cancel. So I have a equals c over x minus b. These are the same. Both of those could be possible solutions. If you're taking multiple choice tests and you have one and not the other, and you don't see it, you have to know that they're the same. Okay? You have to be able to recognize, oh, okay, distribute the x, I can get that answer as well. Okay? And that's tough. It's hard to do. To look at your answer and see that there's actually a different way to write it. All right, let's try another one. I gotta make it bigger, don't I? All right. 2 minus. Oh, I don't want to do this one. Sorry. Just cross it off first. Suppose I want to solve this for a. We'll solve this one for a. So step 1, locate your variable. There it is. I'm solving for a. Now I have to look at the 5 and look at the x and think to myself, how are they attached? Well, when you solve equations, you always get rid of the addition and subtraction first. Is there anything that's attached by addition and subtraction? What? Yeah, the 5. So how do you get rid of subtracting 5? You add 5 to both sides. So I have x over a equals b plus 5. Now, there's 2 different ways to go about it from this point, because what I'm solving for, my a, is on the bottom of the fraction. How do I get that thing out of the bottom of the fraction? That is really ugly. You can cross multiply. This is like a proportion. Put your b plus 5 over 1 and cross multiply. That's what I would do. So I have x times 1 equals a times b plus 5. X times 1 equals a times b plus 5. Now I completely got the a out of the bottom of the fraction. But we're still solving for a. We still want this a by itself. So everything else, how is it attached to the a? Aaron, how is that attached to that a? That b plus 5? Yeah. So what do I have to, opposite of multiplying is dividing. What do I divide by? I want to get rid of the b plus 5. I want the a by itself. So how do you get rid of a b plus 5? This is the hard part. This is hard to think. Yeah, you're just going to divide by the whole same thing. Okay, so divide by b plus 5. Divide by b plus 5. So what's going to happen is your b plus 5 is going to cancel out, and you're left with a equals x over b plus 5. Okay? It's tough. All right, let's try another one. We have a little bit more time. Let me take a good one here. All right, we'll solve this one. This is a fraction. Solve this one for x. I have 2/5 times x plus 1 equals g. We're going to solve it for x. Okay, look where your x is, and how is everything else attached? Well, my x plus 1 is in parentheses, so I have to do that last when we solve equations, because we're going backwards. Okay, subtraction, addition, and multiplication, division. Do I have any multiplication and division?
Yeah.
Tim, what do I have?
You have 2/5 on that.
Yeah, I have a 2/5. I'm multiplying this thing by 2/5. How do you get rid of 2/5? You could divide by 2/5, or when we're talking about fractions, multiply by the reciprocal. Okay, so I'm going to multiply both sides. I'm going to try to squeeze this in here by 5/2. So I have x plus 1, because these are going to cancel, equals 5/2g. I'm still solving for x, so highlight your x, keep track of it, and look, how is everything else attached? Well, I'm left with only the parentheses, so I can get rid of them, because there's no reason to have parentheses anymore, because there's nothing outside of them. So, Josh, what would you do next? How is the plus 1 attached to the x? So we subtract, right. So he's going to subtract 1 from both sides. So can I take 5/2g minus 1 and get 3/2g? Why not? Why can't I? I have yes and I have no. Why wouldn't I be allowed to?
Because it's a fraction. I don't know.
Because there's different, because the one is like a variable.
Yes. Do they have like terms?
No.
Can you add and subtract things that aren't like terms? No. So don't do it. So we have 5/2g minus 1. That's how you have to leave it. You cannot subtract those. One has a g and the other one doesn't. You can't have a pile of M&Ms and subtract Skittles. If I have all M&Ms in my hands, I want you to take a Skittle out. You can't do it. So if you have a 5/2g's in your hand, can you take out a 1? There's no 1's in there. You can only take g's out. You understand? You can't take Skittles out of M&Ms. Don't do it. Somebody will. I'm going to freak out. All right. Try this one by yourself. Ooh, which one should we solve for? We're going to solve this one for C. Give it a try. You got 3 minutes, 4 minutes. See if you get C by itself. I'm going to pause this and give you a chance to start. Yeah, I have the 5. The 5 is attached by addition. Subtraction. What's the opposite of subtraction? Addition, so I'm going to add 5 to both sides. So I have C times x plus 2 equals b times x minus 3 plus 5. Can I combine that 5 in there? No, don't do it. I'm still solving for C, so look, how is everything that's with the C, how is it attached? Multiplication. So opposite of multiplication is division, so I'm going to divide both sides by x plus 2. Now remember, not everything is going to be written like this. It might be written differently. You may have an answer that is the same thing, but looks like this. You have to know those are the same thing. You distribute that x plus 2 to each part. They're the same thing. You also have to know that it could be this one as well. C equals bx minus 3b plus 5 over x plus 2. That's the same thing. I just distributed that one. Any questions? Now, before we leave, I need to talk to you about one more thing. What's this? You should know this, but let's review.
Isn't that for like the Christmas?
What?
Isn't that for like, no.
What's it called? Slope-intercept form.
For the,
The worksheet that I'm giving you, the top 16, I need in slope-intercept form. Y equals mx plus b form. You're going to solve for y and get it look like this. We'll work on how to get it perfect tomorrow, but you're solving for y. These need to be done by tomorrow. I am taking a grade for these, or I'm going to give you a quiz over these. Okay? So make sure they're done for tomorrow.